temperatures. And I think it's really an essential part of this. And what I'd like to do is walk you through our increasing understanding of where we are in the world today, what's happened in the past few decades, and what can we do to be inspired by nature and work to regenerate healthy climate in our lifetime. With that, I will share my slides and happy to take questions as we go along, or afterwards. We'll have a nice chance to discuss. Let's see if that's working. So we're part of a project called rebrighten.org. We have many Rebrighten participants with us today. And this is fiscally sponsored by the Climate Foundation. Very honored, Sumitra, to have this be part of the Healthy Climate Initiative webinar. And it's all about reflecting sunlight, and it's all about restoring our cloud fraction, if you will. With that, I'll get started. I just came across this beautiful photo of the moon with Earthshine, and this is taken from the International Space Station, looking through the pre-dawn of our atmosphere and back out into space. And you can notice a bit of a glow around the dark part of the moon, and that is from the reflection of sunlight from the Earth. And amazingly, in just 20 years, we've lost about 0.5% of that reflected brightness. And so the Big Bear Solar Observatory, here depicted in the lower right, has done these measurements over 20 years and has measured this Earthshine decreasing by about 0.5%. And it caused scientists to really wonder what's going on, to the extent that the Ceres satellite has gotten similar measurements over a similar time frame, and the results have been really amazing. And that is not only 0.5% sunlight loss, but this is the watts per square meter of reflection that takes place. And I believe the blue line is the NASA Ceres satellite, and the black line is the Big Bear Solar Observatory. And these are the results for the last 20 years showing how the planet is dimming. And we think there's a couple of reasons why the dimming is happening. Sumitra mentioned that, of course, the glacial ice is important in reflecting sunlight. And that's shown down here on the lower left, where you've got a white surface, less white than it used to be, reflecting light back into space. But when the glaciers melt, there's more rock exposed and less ice. And the ice that is left during the hot summer months is affected more by dust and aerosols and black carbon, and even melting results in sand and grit being on the top as well. And so that reduces the reflection of sunlight. In addition, Professor Tapio Schneider at Caltech and others have been demonstrating that, in fact, a warmer planet is one with fewer marine clouds. And these marine clouds do a great job of reflecting sunlight during the day and emitting, these clouds are warm, emitting infrared heat into space at night. And that's a really key aspect. This is a good qualitative picture of all sorts of approaches to reflecting sunlight. And here's a more quantitative analysis of the 100 watts per square meter that is reflected back into space, at least historically. But when that changes by 0.5 watt per square meter or more, it's enough to have a substantial difference on the decreasing the amount of reflected radiation, sunlight, which means more is absorbed at the surface, and that causes a problem. And you'll notice that if there are clouds, the difference in the infrared is about 50, whereas when there are clouds, the difference in reflected is about 100 watts per square meter. So more clouds generally mean cooler because there's more reflection, and there's only half of the infrared is absorbed in that sense. And then so it's really a combination of the cloud reflectance and the ice that is causing this problem. Now, I will mention briefly the ice situation, and that is, first of all, there are fewer clouds in the air than there used to be. But then secondly, the ice is declining. And I think we might have this is a NASA summary looking at the last 40 years or so of sea ice in the Arctic. And amazingly, it's gone from 7 million square kilometers and dropped and dropped and dropped in recent decades to the point where we really only have half the ice we used to have in the Arctic. And by the way, at the North Pole in the summer, you get more sunlight at the North Pole than you do at the equator because it's 24 hours a day of sunlight. That's how incredible this is in terms of heat. What this means is that each year, the absorbed solar radiation vastly exceeds and increasingly exceeds the emitted thermal radiation. And this difference in energy represents ocean warming and heating of the Earth. And it's profound and substantial. It's been tracked by Leon Simons and others. And it's actually increased dramatically from 2000 and the 2010s, where it was almost zero difference, till now it's over 1 watt per square meter difference and expanding. This has been tracked by Leon Simons and others. And you'll notice just very recently that this imbalance has become more extreme. And that has a profound effect, almost as big as the CO2 effect in terms of watts per square meter of forcing. This net forcing is 3 watts.
One sec for a few seconds. Just wanted to give 1 watt per meter square, that imbalance, what it means, just in
Yes.
quantity term. I calculated that, and it came out that every 24 hours we are exploding 700,000 Hiroshima-sized atom bomb every 24 hours. That's what it means by 1 watt per meter square imbalance.
Yeah, thank you for that, Sumitra. And I think this net forcing by aerosols and decreased clouds and whatnot of nearly 3 watts per square meter is profound, rivaling the 4 watts per square meter of greenhouse gases under doubling, which we're now already experienced. The result is more than 90% of this heat is going into the oceans. It's having a profound effect. And relating to that are the sulfate emissions that have been historically condensing these clouds. Most of them man-made. This is like 90% man-made aerosols from shipping in the past, but that has recently gone away. And because it's going away or has gone away, it's having a profound effect on the oceans. In particular, we've seen through 2023 these record levels of temperatures. And you'll notice the IMO in January of 2023 cut the shipping aerosols in the North Atlantic, North Pacific, and notably Indian Oceans. And the Indian Oceans are very profound because they're major shipping lanes going right past Tamil Nadu. And so it can have a significant effect on the aerosols that are reaching that region. And just 6 months later, we were seeing record high temperatures. And in fact, those record high temperatures have remained to this day. This is an interesting animation showing around the year the temperature exceedance from the 1900s all the way through to the 2000s. And what's amazing is that how the rate of warming has accelerated. These red zones represent significantly more than 1 degree of heating. In fact, I have a chart later that will show that we're presently close to 1.6 or 1.7 degrees of heating, which is really profound. In addition, it turns out we're losing some ecosystem services. Over the past decade, we've researched with the Climate Foundation on marine permaculture the extent of kelp forests in the United States and Australia. And we can account for 1/3 hectares lost off the coast of California, this example in Santa Barbara, where we used to, in the 1800s, have a continuous river of kelp, a 1/2 kilometer wide, that not only fixed carbon and actually drew down CO2 levels and provided fish habitat and ecosystems, but also was producing biogenic aerosols and cloud condensation nuclei that help to keep the marine cloud layer bright. Now today, you see just a little vestige here of the kelp forest that once was, and it's dramatically different, partly because of siltation and runoff and other factors. And so we think that there are multiple nature-inspired approaches. The kelp forest is profound. No one has a memory of what it was. But between that and the historic, for a century, we've been putting out these ship tracks. This is off of the coast of Europe. And you can see both the brightness and the particle sizes there. And yet, in the last 5 years, since 2005, last, I guess, more like 10 to 20 years, the amount of sulfates has dropped by 80%. And it's been cut by the International Maritime Organization. Just from 2015 to 2022, we've seen this dramatic drop. And then there was, in January 2023, a further drop. And the result has been profound on temperature. Now, this shows from 1970 to 2024, the global mean temperatures, and it's color-coded. Blue is cool temperatures, normal temperatures, January at the top, December at the bottom. But as you see, it goes along, it gets warmer and warmer and warmer. And what happened in 2015? We've got this big line, and then it's just hotter and hotter and hotter. And right now, we are between different months of 2024. We're 1.5 to 1.8 degrees Celsius above normal for global surface air temperature anomalies, with an average of 6.
That is a great chart, my goodness.
Yeah. And this is thanks to Leon Simons. He put this together. So you can see James Hansen is right. We are getting 150% of the global warming that we had just a decade ago. The rate is accelerating. And the results have been profound. When IMO set their final regulation for the international waters in January 2023, by June of 2023, we were seeing sea surface temperature anomalies in the North Sea that were 5 degrees Celsius above normal. Really profound. And this stretched across Europe. And then furthermore,
of our community just a few hours ago in the Florida Keys, and it revolves around the incredibly warm water temperatures that surround the Florida Peninsula. Now, there's a number of buoys all across the Florida Keys, but at about 3 o'clock this afternoon, the buoy at Murray Key measured a sea surface temperature just less than 5 feet below the ocean surface of 99.3 degrees. Now, as if that wasn't incredible enough, a few hours later, a separate buoy in Manatee Bay, which is a little closer to the Key Largo area, measured a jaw-dropping figure of 101.1 degrees. Now, if this verifies, and I'm sure they're going to critique the numbers quite a bit in the next 24 hours, but if that verifies, that would set a new world record for the warmest sea surface temperature that's ever been observed by humans. And it would break the current record of 99.7 degrees that was observed in Kuwait Bay in the Persian Gulf in the Middle East. So this is really quite incredible. Now, for some perspective, the water temperature averages in this part of the Florida Keys during the month of July only average in the mid and upper 80s. So the fact that we have water temperatures now that are at or above 100 in parts of the Florida Keys is just astonishing. And it's not only in the Florida Keys where water temperatures are running way above average. This is a water temperature anomaly map. So the darker the red, the higher the temperatures are above average for today's date. And they are exceptionally warm across the northern Atlantic. There's only one small swath of the ocean right now where temperatures are below average. And that's because that's where Hurricane Don was swirling for the past couple of days. So it pulled up some cooler water from deeper in the oceans and then kind of cooled off the water temperatures there by a bit. So, I know I don't need to tell you that we don't need a hurricane this year, but we really don't need a hurricane that's encountering water temperatures close to 100 degrees. It's simply mind-blowing what's going on right now with the water.
So all this to say, it's a profound effect. And by the way, that place off Key Largo was the place I got to my first coral reef half a century ago. And unfortunately, the Sombrero Reef didn't bleach during that summer of 2023. It just died. Many or most of the corals off the Florida Keys are probably dead from that heat wave. So it's a profound effect. And it's one that, is very sobering. And the fact that this happened from the inadvertent well, it was intentional to cut the aerosols, but this inadvertent side effect of losing the marine aerosols has had a profound effect on nature. So just wanted to share that with you because I found it to be so poignant. Now, there was something interesting that I do want to mention, and that is he mentioned how the hurricanes actually cool the water. And the way they cool the water is by upwelling deep water. And that's exactly what we're looking for with marine permaculture. And so it's a little silver lining in the sense that upwelling and deep nutrient supply and deep water supply can actively cool during the summer months and contribute towards cooler coastal temperatures as well. This slide shows just for 2024, not only five major hurricanes that came through this Florida region, but also 18 named storms, which is about 3 times as many named storms as used to occur some 5 decades ago. So it has a profound effect. And of course, we've all seen flooding from the Indian subcontinent to the United States and Europe of these profound effects. This picture from the coast of Valencia, Spain, was before the major torrential rainfall. And if you look at this region, this is a very flat region, but just fine. And then afterwards, just a huge amount of siltation and runoff, catastrophic results. And of course, we can attribute this to the the challenges that we're facing with an exceedingly warm ocean. Now, the critical zone is actually the tropics, because at the end of the day, the wet bulb temperature is inconvenient for the global north and the higher latitude countries, but is a risk of survival in the tropics. And that extends to northern Australia, across the Indian subcontinent, and even up towards the Florida area. And it's been said in the past that, the theoretical adaptability limit would be a wet bulb temperature or a dew point of 35 degrees Celsius. But in reality, when they did physiological experiments, they found at the lower temperatures, 30 Celsius was about the highest wet bulb that could be supported. And as we go to higher temperatures, 28 to 26 degrees Celsius would be the maximum wet bulb temperature that could be sustained for several hours. These tests were done with young, able-bodied men in prime fitness, and actually the frail, the young, and the elderly would fare much worse than this. So this is a very sobering fact that is brought forward in key book, The Ministry for the Future. Chapter 1 describes a scenario where in the not too distant future, we could be losing millions of lives starting in the tropics when these temperatures occurred. Now, Sumitra related to me how hot the temperatures were in the Bay of Bengal in 2023. And when I did some research and got these temperatures, I realized not only is there the normal peak that occurs in April, but when the monsoon fails in May and June, we have temperatures of 39 degrees Celsius for the first half of June. And I think Sumitra can attest personally to how unbearable these temperatures were even in 2023. And as the temperatures continue to rise and accelerate, a failure of the monsoon in these critical solstice months of June, for example, can have fatal consequences for people living in the tropics. So we're looking at how we could actually ensure that the monsoon can be replicated. These are some studies of the sea surface salinity and rainfall. And I think it's all about ensuring that the monsoons can continue. And I think that's an essential part of what we're looking at with Rebrighten, to ensure that monsoons can continue in a reliable way. So with our Rebrighten project, we're asking, how can we be inspired from nature and regenerate marine clouds using nature as a metaphor? And one technique is to recognize the sea spray effects and the profound effects that sea spray can have on natural cloud condensation nuclei. And so I think drawing some notes from inspiration, we have the benefit of Professor Stephen Salter, who did several decades of research on artificial ways of using wind power to generate these sea sprays, if you will, and more recent work with our marine permaculture platforms to consider the substantial amount of natural biogenic aerosols that occur with the seaweeds that grow on these seaweed platforms offshore that could actually contribute to cloud condensation nuclei. Those are these blue dots, and potentially contribute towards the coastal marine clouds that are keeping me cool today here on the coast of Queensland. How this works is that as the seaweed grows, some decays and it actually gives off these biogenic aerosols that turn into cloud condensation nuclei, and the converging winds actually enable the upward transport of these nuclei and divergence. And this works with a sea spray, and it also works with the biogenic cloud condensation nuclei. In fact, there's a long history of studying the sea salt, and the sea spray in the size of 100 nanometers to 800 nanometers has a lifetime in a growing condition under relative humidity conditions and conditions for growth. And this was back in 1936, this research was done. So we've had more than half a century of R&D. We stand on the shoulders of giants, including the late, great Professor Stephen Salter. And we're looking at, this history of 50 years, including Alan Gadian, who's active with us now on the Rebrighten project, and Latham and others. The Twomey effect dates back 50 years, and that is when you create more cloud condensation nuclei and they're smaller, they actually cause brighter clouds. But I think equally, if not more important, is just the cloud fraction, and that is how can we increase the percentage of clouds that we're dealing with. So there's a long legacy, and the time is right to progress to the next steps. And so we're interested in developing a menu of options for coastal cities across the world, and especially in the global south, to enable localized marine cloud rebrightening solutions, to enable that can occur with sea spray, it can occur with seaweed forests. And in fact, there is a new initiative that Prime Minister Modi has just put out that I'll mention in a moment. And I think there's an opportunity to demonstrate at small scale sea spray demonstrations, measure the cloud condensation nuclei near seaweeds, and do some trial small scale testing in tropical regions. In particular, just a month ago, Prime Minister Modi has declared a boost for the local economy. They're aiming to go from 34,000 tons of seaweed production this year to over 1 million tons of seaweed production next year. So we're leaning into this opportunity. The mandate's only partially funded, so we're going to need to find private matching funds. But this is an opportunity to have a big effect. And even, in this case, it's wonderful to have the support of the federal government, the Commonwealth. But even when that isn't the case in some other countries, we can act at the local level and the regional level with bottom-up, small-scale operations, because after all, regenerating these marine clouds can be done locally and regionally, and that's a great place to start at the frontier of what we're doing. So we're interested to identify communities that can work with us to build calls for proposals and requests for proposals, and actually to raise the resources and the funding that's needed to develop community projects that can begin to rebrighten our planet. And with that, I will thank you and turn it over to a conversation for a brighter future.
That's a wonderful talk, Brian. I will open up for questions. I definitely do have a lot of questions, but I'll hold that for the later part of this discussion. So with that note, please raise your questions. And let's make it interactive. Okay, Janet?
Yes, just be the role here. I'm just wondering. Go ahead.
Okay. Okay, if I'm on first, I guess. Brian, great presentation, wonderful slides. One of the things that I've been trying to come to grips with on the sea spray side of the marine cloud brightening is what is the prognosis now for successfully developing the fogging technology that could be the basis for the process, and how many years do you think it will be necessary to finish off the technology that would be the basis of that process?
Well, I think it can be done relatively soon. Fogging usually refers to larger particles, let's say 10 microns in size. And that has been done a little bit on the Great Barrier Reef, with some concerns about the total energy required. What's interesting is that with marine solar, we anticipate being able to do submicron sea spray, and that will actually evaporate much more quickly. It actually has the benefit of not moisture robbing downwind. And I believe that they're going to be proposals have gone into the UK government through ARIA just a week or two ago, including some by ourselves. And I expect we're going to be hearing next quarter about those. So the research will continue. But I think equally urgently to the research by the Global North is we need to begin the community engagement in the Global South. And Sumitra, I'm very happy to say, is going to be leading a series of town halls in India. And we're hoping to do a webinar in partnership with the Bay of Bengal, West Bengal, and Bangladesh, potentially. And this is going to be about community capacity building, because I've learned through our work on doing marine permaculture in Tamil Nadu, India, that community-led projects actually get a hall pass, if you will, when it comes to local, municipal, and regional and provincial regulations. Because if it's community-led, it's presumed to be in the interest of the community. And so that's actually significant in perhaps one of the most bureaucratic countries in the world. And we see this across Commonwealth nations. But this inspiration of bottom-up, grassroots, I think this is a case of radical transparency, that there's the potential for communities to reach out and say, we want to be part of the future. We want to help lead the way on how we can protect our citizens and our residents from climate disasters in the future. And that's going to be about the cloud fraction and rebrightening. And so I think we need to do that social impact work. And I think we could be doing that next year. In fact, next month, I'm looking forward to helping Dr. Sumitra in the showcasing the town hall meetings and the local local government engagement. Thank you, Dennis.
Yeah, thanks, Brian.
So the next one, okay, I think Robert Tulip and then Carol.
Thank you very much, Brian. That was just brilliant. I've got two questions that I'd like to ask, if that's okay. The first one is about clouds, and I thought that your comment from Santa Barbara Channel was just so illuminating. Just the idea that California could cool down their weather by restoring their historic kelp forests seems like a really simple one. And one of the issues that comes up with clouds is that I think it's like 60% of albedo, or maybe a bit less, comes from clouds compared to ice and snow and aerosols. And go on.
Yes, I believe that is true. And the cloud fraction is critical.
Yeah. So Franz Oester made a really interesting comment the other day, which was that for every cloud condensation nucleus, that it generates reflective liquid water fraction in the cloud. And it's a really interesting contrast to stratospheric aerosol injection, where you've got to lift a particle of sulfur up to 60,000 feet, and then that particle will be very reflective for a long time, but it won't catalyze all of that water in the way that MCB does. So I'll leave it with that. Just, I suppose, the prospects in Santa Barbara to cool down the coastal areas, and the comparison with SRM as with SAI, stratospheric aerosol injection, as a cooling technology.
Yeah, I think there's a really important distinction, and that is when we start and we want to take incremental steps and find projects that are fundable. We've raised about half the funds to do the first pilot project in Santa Barbara, and we're looking to raise the remainder. We can start small, and the time scale for these natural biogenic cloud condensation nuclei is just about a week until the next rain. And after that, then we're back to normal. So it requires a continual presence of a healthy kelp forest. in order to keep those benefits going. So the project, the effects are shorter term, but it also means the consequences are much easier to characterize, and it can be done at a hectare scale, and it can be done by local and provincial and state governments rather than requiring a federal or a multinational agreement. And because it can be done locally, it is a great opportunity to move forward at small scale and to be able to demonstrate the benefits and enable more communities to adopt these solutions locally for themselves. So I think that's a key aspect, perhaps.
And on the comparison with SAI?
Well, I think we need to, I've seen it said recently that we need all the different renewable energy sources that we can get hold of. And I think literally we need to work with all three legs of the climate triad. And that includes emissions to zero. It includes 2,400 gigatons of carbon removal, and it includes climate repair. And we need to create that menu of choices for governments to choose from in the global south and the global north. And we just like to include the sea spray aerosols and the biogenic aerosols from algae forests on that menu list. And of course, SAI would be on that list as well. And ultimately, it's up to the governments to choose what they're going to do and which ones can be done locally and regionally. But we're keen to actually get boots on the ground and fins in the water on local and regional projects that can move forward next year. And I think that's the way to do this, with a lot of transparency, with community engagement. And we're looking forward to raising the funds that would enable us to put out a request for proposals to work with communities, particularly in the global south, to enable this to move forward in a well-governed way that would enable small-scale testing to be done and a good level of transparency so that it can go forward with that community discussion. Thank you.
I want to add, before I take the question from Carol, I want to add one more thing, that some of these solutions are quite controversial in the global north. And one way to bypass that is to go to the global south, where people are hurting and more open to such solutions with the communities, involving community in a local small project to prove this our technologies and perfect it, create the governance model in those countries where that is more open to accept this solution, and then come to the global north, the same, come with the solution. And this is what I call as Huawei strategy. Huawei, if you know Huawei, this is what Huawei did. They became the number one telecom providers today by taking, targeting the global south first, and now they are the number one. So this is the similar strategy we are thinking, focusing on those countries where the people are hurting, working there, creating, making it better, and then come back to global north. So that's my, with that note, Carol, and then Dee Ghoshal.
Thank you. Interesting about Huawei. Those phones were very, very popular in Kenya, where I was living at the time, before I ever heard about them here. And I think between the two of you, Sumitra and Brian, you may have answered this, but I'm still interested in how, when you're getting acceptance from local governments and communities, I guess putting out an RFP, especially if it has money attached to it, is a really good way of doing it. But I learned recently that the folks from the University of Washington who tried to just test their gadget in California and got shut down by Alameda, apparently, the way it was reported, it sounded like they had just gone in there willy-nilly and were really irresponsible. But in fact, apparently they had done all kinds of public engagement and they got shut down anyway. So I'm wondering what thoughts you have on that, making sure that it goes forward.
In general, I think we need to prepare the communities that are applying to us that they will probably get a media onslaught, and there'll be an attempt to divide the community because there are vested interests that really are committed to emissions only reduction. If I may borrow a phrase from Peter Fikowski, he said, it's a suicide pact of the IPCC and the United Nations COP, to do emissions only reduction when we know full well
Right. Sure.
for the global south, for example, for the tropics. I mean, it's going to be lethal. It's a matter of survival there. And so with that, I'll turn it over to Sumitra and ask you, Sumitra, what kind of social acceptance questions and what is the initial local government reaction to these questions about climate repair strategies?
So there are, multiple ways I'm approaching, or we are approaching this. We are going to the municipality level, and often some of the people, I know them personally, so they are more open to listen to this, right? And so you're engaging the local people who you have already trusted relationships for a long term. It's not a one-day relationship. It is for years of relationship, 20, 30 years of relationship. I do have with some of them. The family relationship, they are more open to hear these things, and they can make the decision within themselves because of they understand, they trust. That is the number one. So we start from a very small place, and then take it bigger. What you want first to show that it worked, to show that there are some areas of concerns, you address them, but in a heartfelt way. And Indian government allows you to do R&D at a small scale. There is a provision in the rule to do that. So you take that also into consideration. So legally, you are within the law, you are with the community. And on top of that, what I'm doing, I'm going after 10 cities every year to organize workshop, asking 200 people in each workshop to come, 250 people in each of the workshops. And at this time in January, I have 6 workshops lined up. One is the east part of India, which is in Assam. Then in Hyderabad, there are 2. One is IIT Hyderabad, and then there's another private university. Then Bombay, I have one IIT Bombay, one place, workshop one day. And then Delhi, you are targeting Delhi University. And in these places, we are taking the media, policy influencers, the members of the parliament, inviting them to be part of it. So I do not think that it's one day this is going to be solution. So we have 5-year plan for this. So we are going to hammer this message over and over again, the same thing over and over again, until it becomes clear to them that this is very important. And every year 10 workshops. That is the plan, at least 2,000 activists, creating 2,000 activists. There will be a global conference on this particular in Delhi, asking even Prime Minister to join this. So maybe first year we may not be able to get that, but in the future, I'm hoping that we get that level of interaction within the parliament, in the community, in the media. So ultimately becomes a national conversation leading to a national cooling strategy.
Wonderful. I think D. Ghoshal has his hand raised.
Hello, can you hear me out?
Yes, we can hear you fine.
Yes.
Yes. Actually, thank you for the wonderful presentations. They really were enlightening. I have got one apprehension in the sense that Marine Cloud Brightening, although it is a technological fix, no doubt, but it could disrupt the regional weather patterns also, is my apprehension, such as monsoon and affect the ecosystem. Now, altering cloud cover, that might also impact the precipitation and ocean circulation in some unpredictable way. But for any model, say with the supercomputer, I think even in quantum computer level, really can we really predict how the ocean current will change, particularly if it changes the marine highway, like it happened in Amok. And one important event happened in New Zealand
I think he might have
Mm.
glitched
So
a little bit.
basically, here the question is that the unintended consequences of marine cloud brightening. So that's what the question.
Yes.
Enlighten me on this point.
I missed part of it, but I think we can talk about the consequences. And first of all, I think it's important to recognize that even over the last 20 years, we've lost 0.5% of cloud brightness and some sea ice as well. And so just getting back to pre-industrial levels of brightness is important, partly in the case of the Bay of Bengal, is to keep the monsoons occurring steadily by the May and June timeframe, which is very important for the summer solstice temperatures. So I think there's an example or an opportunity to actually get back closer to pre-industrial levels and do that locally. And so I see that as really a key aspect. In addition, when we are choosing the sea spray aerosols, we're not just adding the cloud condensation nuclei, but also some moisture to the air, which actually provides somewhat of a evaporative cooling effect. And so it can actually reduce the temperatures tactically. It can, most importantly, increase the cloud fraction, which means that over a period of several days, there's more reflected sunlight back in space and lower temperatures. And then finally, the lower sea surface temperatures can actually reduce the amount of warm water fuel available for hurricanes, cyclones, and typhoons. So I think we need to proceed step by step. We need to start small. And, I would say the comparison is not a pristine environment that we had 100 years ago or in the last century, but the comparison is, do we work to cool our municipalities and regions, or do we allow business as usual, which could accelerate a ministry for the future scenario? And we, I think, have a pretty good handle on where we're going. And so really it's what is the hazard of not doing anything? I think that's something we need to compare to. That could be. Thank you for your question, Digoshal.
Yes, very well said. Thank you so much.
So my next, I think, John, then Peter Fikowski. John.
Thanks, Brian. In terms of biogenic aerosols, in a recent call you mentioned the very promising aspects of ulva seaweed in terms of protein and growth, DMS. Can you expand on that for the group, please?
Yes, we found dozens of species that have prolific amounts of biogenic aerosol materials and precursors. These include concentrations of 6,000 to 9,000 parts per million. Now, the super seaweeds like ulva, for example, they grow quickly. They can double their size in just a day. They occur in the world oceans, from the equator all the way to UK latitudes and all the way down to Tasmania, I believe. And they grow prolifically. They're a high protein source for food security. And as we're ensuring food security for humanity and millions of other species, I do note with interest, the fish like eating the ulva even more than the seaweeds that we're growing commercially in the Philippines, near where Dennis lives. It has this food, feed, and fertilizer dimension to it. And because it grows quickly and it produces large amounts of the biogenic cloud condensation nuclei materials, it would be very interesting to see and measure the concentration that we can achieve starting in the Philippines, but even going to other regions, especially with the plan to grow so much more seaweed in India in the coming years. A chance to really measure the powerful effect that can occur as well as other kinds of seaweeds. Thank you, John.
Thanks.
What kind of seaweed are you saying, Brian?
It's a green seaweed. It's called sea lettuce. And there's like 50, probably 4 dozen species that might be of interest, but grows across the region, across the globe, I should say. Over to Peter.
Peter.
Okay, here we go. I missed the first part of this, so I apologize if it was covered. 2 questions. One is how, in brief, how do you show that it works? Like what's the test and what's the evidence that says, oh yeah, this works?
Well, it turns out I have with me some consumer grade PM detectors, PM 2.5, PM 1, PM 0.3. And there are also professional grade levels of these. But we can actually measure the concentration of cloud condensation nuclei immediately downwind of the interventions.
Right.
Right? And we could also have the measurement of biogenic aerosols downstream as well. In addition, we can measure the precursors to the biogenic cloud condensation nuclei and measure the difference in concentration of those precursor gases that occur that give the beach the smell that you get, with the sea spray and the kelp on the beach. It's a very natural effect. And if you look up or down the beach, you'll notice the haze that's actually a marine cloud nuclei. And so next time you're down on the beach, look up and down the coast and notice that haze that occurs along the coastline. And that's actually attributable to many of these natural and biogenic aerosols that can have a profound.
Yes. So Brian, the question is, I mean, that's nice. We've all seen the haze at the beach. And so there's no question that that part of the phenomenon works. But you're expecting it to do some cooling. And that I think is, I think, tell me if I got you right, that you're saying, well, we should definitely fund the seaweed production because that's a sort of a no-brainer. And then I think you're also saying that if we do that, then we also are funding some marine cloud brightening. Did I get you right?
I think we don't know the answer completely because we haven't done the system level intervention. But what we can do is as we're growing the seaweed and maybe doing some sea spray, we can measure the biogenic aerosols, we can measure the cloud condensation nuclei, and we could perhaps, using drones, and this is proposed but not funded, we could actually measure the cloud condensation nuclei lifting up to the base of the cloud layer, which would be typically less than 1,000, which would be an.
So Brian, the question I'm getting at is if I were a government official, maybe a funding official, and you said, okay, cloud condensation nuclei, and I Google what does that mean and how do I spell it? That's not if you're claiming that it'll cool things and make a better climate in California, you need to actually demonstrate that. So my question is, if you were to demonstrate it actually had an impact on a microclimate or a regional climate, how would you measure that?
We could measure it by satellite and by drone, as I mentioned an example already.
And then, okay, good. That was that question. And what would it cost to do that? Like to actually do the implementation at the scale needed to make a measurable difference and measure the difference. What's the budget for that?
Well, the proposal that we put into ARIA was for several $1 million, and that would be enough to do a multi-year study that would do many steps of that causal chain. Would it do all the steps? Potentially. And I think that while it may be expensive to do the first few research studies, our intent is to implement it for order of magnitude less when we're going to communities and going to larger scale.
Right. So I hear you saying that a few $1 million will give you a test that will show that you can produce a regional impact.
I would call it a local impact at that
local
scale.
Impact. Okay, good. And that if you can do a local impact, maybe you can do 10 local impacts and cause a regional impact. Okay.
Yes.
And then the final question is, who would logically fund that? No one in California would fund it because as Carol pointed out, no one wants to have geoengineering within 100 miles of them politically. And but so who would fund it? Because I can't imagine the EU is any different. I cannot imagine ARIA would fund it because they would be accused of actually cooling the planet, and that goes against the UN.
Well,
who would actually fund it?
I'll answer that in two steps. The first is to note with interest that the very definition of geoengineering is either global or large scale. And because we are local and regional, arguably this is about food security and enabling the residents of a community to manage their local weather, their local temperatures. So I would suggest that in fact, this is something that can be done with local and state governments. The second is that we need to find organizations that have an appropriate timescale. And I will take a page from your book, Peter, in looking to intergenerational family offices that have an appropriate timescale, in looking to sovereign funds that need to build pensions for their constituents over a period of decades and enable and ensure the continuity of those. And then finally, to look to reinsurance companies that are tasked with reinsuring $5 billion worth of reinsurance, for example, for Florida. And in some year very soon, Florida will become completely uninsurable when it comes to these hurricanes. And if we can kick the can down the road, if we can actually help to cool locales and regions and municipalities enough to deprive some of the wind of the hurricane, a 10% reduction in wind hurricane strength is enough to result in a 30% reduction in damage. And that turns a $3 billion hurricane into a $2 billion hurricane, or in the case of Houston and Florida, a $180 billion hurricane into a $120 billion hurricane. So literally reinsuring the reinsurance industry would be a long-term and scalable approach to actually addressing this. And hopefully the reinsurance industry has the appropriate timescale in mind. Thank you.
Great. And have you drafted a proposal for that?
I have not reached out sufficiently yet to the reinsurance industry, and I would welcome partners who would like to introduce us to the reinsurance industry. And, I think we should put a banner out there saying we're ready to reinsure the reinsurance industry when it comes to these hazards.
Right. Great.
Thank you.
Thank you.
Thank you, Peter. Vihara Foundation, and then Paul, then Robert.
Hi. Just want to commend that your presentation is it reminds me of the Al Gore presentation. So, back in 2006. So we're going back like 18 years. This is very convincing. But more importantly is I have two questions. I just want to find out, I'm working very deeply with the government of Los Angeles and the philanthropic community of Los Angeles. And now that you've brought up the issue of the kelp forest degradation, I would like to know, first of all, what is the main root cause contributor for the diminishment of the kelp forest? Is it pollution, or is it atmospheric oceanic temperatures? And if you can explain that, can you explain what is the rehabilitation process for building back the kelp forest in that region? And number two is I am working with a conglomerate of family offices based in Los Angeles that is particularly interested in funding projects like these. Let me know if there's a possibility if we can possibly repeat this presentation or give a copy of the recording to that group, because I strongly believe that they will play a strong input in helping a project like this, if there's a viable solution for maybe rehabilitating that kelp forest and making this a demonstration project for replication around the world.
Yes, thank you so much for that question. And the problem in the Santa Barbara Channel and all of Southern California is that the water's too warm, the nutrient levels are too low, and there's actually a nutrient value chain gap between the seaweeds that exist today and the deep nutrients that the seaweed depends on for survival. And so we've developed a marine permaculture approach where we actually lower the platform at night and the seaweeds absorb the nutrients in the deep water. And then we raise the platform at sunrise and they absorb sunlight and carbon dioxide in the top meter of the sea. We've raised half of the funds so far with a couple of family offices in the Santa Barbara area to build America's first pilot marine permaculture deep cycling platform that would enable showing the way for interventions in Southern California and beyond. And in many ways, I consider the Santa Barbara Channel to be the gateway to Southern California, because when we demonstrate our ability to grow red, green, and brown seaweeds in the Santa Barbara Channel, it's immediately upwind of the Los Angeles Basin. And when we restore the marine cloud condensation nuclei in the Santa Barbara Channel, we will actually be restoring the marine clouds and their brightness for perhaps potentially the entire Southern California basin. Thus, whatever we do there could actually be scaled beautifully across the Southern California basin. And literally, with 50% of the funds raised, this is the ideal time to actually reach out to other family offices in Southern California and see if they would be willing to match the funds, enabling the pilot project to go forward. And we have a team ready in Southern California to do this. So I'd love to follow up with you afterwards. Perhaps we could share the recording and actually follow up with team members that would be interested to see if we can raise the remaining 50% of the funds needed to demonstrate America's first pilot scale marine permaculture platform.
Sure. So let's connect through Dr. Sumitra and get this going.
Absolutely.
Wonderful.
Absolutely. And I'll send you the recording, and,
sure.
I know both of you.
Because I believe this can be also replicated in the Caribbean and India and all these places,
Right.
Exactly. That works very well.
Thank you and congratulations on your hard work.
Oh, thank you so much.
Paul?
Yes, thank you, Brian. A great presentation. One thing that you might want to add is show some footage of scuba diving among the kelp forest. I've actually done that in the late 80s in the Channel Islands. And I mean, the kelp is quite amazing because most of it is just leaf, right? It's got these little buoyancy components. So the stem is doesn't need to support the weight. And it can extend from the seafloor up 100 feet plus to the surface. It's just amazing, and there's a huge diversity of life that lives within the kelp forest as well. Almost as much sea life as coral reefs. So, to restore them would be amazing if that could be done. I think one of the key points to consider is how to send the biochemicals that come from the marine life, how to get them aloft, because we're in a warmer world, there's more water vapor in the atmosphere, so why do we have lower level clouds? And I think the main reason is that the convective uplift is the key factor. So, you showed the kelp beds or marine plankton beds, and you showed converging winds creating this uplift. Is that natural converging winds, or are you talking about generating these converging winds somehow?
Yeah, just to answer that first question, there's actually cloud streets that occur, and these are actually in the direction of the wind. You end up having the equivalent of Langmuir cells, which are convective rolls that occur whenever you've got a sea breeze over the water. It actually will produce these convective cycles, and these can be observed actually by satellite under some conditions. And so I think what happens in a warmer world, often we get some more evaporation, but the lifting condensation level also rises. And so if that goes above the mountain level, then in fact the moisture can go right over and beyond the mountains rather than getting rained out there. So there's several effects going on, and it's complex, but the research of Professor Tapio Schneider at Caltech and others has been indicating, in fact, less clouds in a warmer planet. And so that's a bit of a delayed and amplified feedback, unfortunately, that we have to be prepared for.
Okay, and then I guess, is anybody contacting we need some good lawyers to contact the IMO and threaten to accuse them of murdering the coral reefs.
That's a good
right?
point.
I mean, we can do attribution studies that them taking sulfur out. I mean, who decided to do that? Was it the head? I mean, generally, maritime shipping fuels are the worst quality fuels, right? They're the crud that's left over, so it has high sulfur up to now, and they figured out, well, let's just clean it up. So who's making that decision? And they can't claim ignorance that they don't know it's affecting the climate. So if they're pointed out that if they're shown clearly that they're contributing, or basically they push Florida over the limit and they basically murdered the coral reefs in Florida. Surely there could be international lawsuits. And the good thing is that the system is much more sensitive to sulfur than we expected, right? So if the sulfur is put back in with the idea of let's remove it long term, once we have time to do some of these other interventions, so that we don't lose all our coral reefs, for example. So do you know of anybody looking at that angle? I mean, I know James Hansen was just at the Hague with his lawyer, Dan Galpern, last week in front of the International ICJ or something, International Criminal Justice people, to try to argue a case for, representing more, some of the island states, I believe, to get a voice at this, Hague International Criminal Justice group to look at it from that angle. I don't know how successful that's been. Remains to be seen. I mean, they're going to take a few months to deliberate, the judges, and vote on it. I'll talk to Dan about that sort of angle. Because the attribution studies show, we've pushed the coral reefs over by removing sulfur from shipping fuels.
Yes, well, Dennis Garrity is helping to lead the Healthy Climate Action Coalition, Healthy Planet Action Coalition, HPAC, and I believe there's been an open letter written by many HPAC and other members to the IMO, and that letter has been delivered. That's not quite a lawyer letter, but it's a letter. And of interest, the IMO regulations went into effect between 2015 and 2023, January, but that was for international waters. It turns out in May of next year, the regulations go into effect for the Mediterranean. So they clearly know about it now because we've written letters about it. And it's locked in the Mediterranean, and we see Valencia in even worse shape than it has been this year. Then there's going to be a huge amount of damage, and the challenge is going to be to consider maybe not the original sulfur, but maybe some benign aerosols, whether it's sea spray or kelp forest or aerosols or cloud condensation nuclei. There's probably a variety that can be done behind ships and can be done in coastal regions, and we need to find an alternative and get that funded, maybe even by the IMO. So let's work together to make that happen. Thank you.
Right.
Yeah. And,
my last question is if I could get a copy of your slides, I'll promote it on my channel, and we'll have you on the Climate Emergency Forum soon to promote it on that channel as well. We're getting lots of subscribers and viewers. So thank you very much.
Thank you, Paul. Dennis,
Brian, you sent that, the slides to me. I'll distribute it. That's my plan. And I also will post this recording throughout.
Yeah, and I would just say that we'll follow up with you, Paul, about the IMO letter and the initiatives that you're discussing, and maybe we can coordinate on that because we have a major effort going on. Brian is a member of the steering circle of the Healthy Planet, and we've got a major effort to try to get the IMO to reverse its regulations.
Thank you.
Thanks.
Robert, and then Dr.
Brian, you quoted James Hansen and others as saying that the albedo has fallen by 0.5%, and I just want to clarify that, because in the chart that you showed from Big Bear and Sarah's, it showed that the albedo had fallen from 100 to 98, which is by 2 watts per square meter. So if you're considering like how much are we reflecting back to space, used to be 100, now it's 98, so that's a fall of 2%. But where the 0.5% comes from is that you look at how much sunlight's coming in, and so that's 340, and so I just think that that's the wrong denominator. Like I think it makes more sense to say albedo has fallen by 2% because it used to be 100, now it's 98. Like at the extremes, at the peaks, it's like 3. So there you are.
That's a good question, Robert. And I suppose at the moment we're just we're looking at it that it's 2 watts per square meter over 340. So it's just over 0.5%. But I think we should take a good look at it and identify the best ways to put this forward. And by the way, I want to send a big thank you to you in helping to prepare the slides, and also to Ron Swenson and others, because this is a new set of slides. It's relatively new material, and I really thank everyone who actually helped bake the cake and put it all together. So thank you all for that.
So, Dr. Sharif, I think you are the last one in this question answer session. Sharif?
Yeah, can you hear me?
Yes.
Yeah, thank you. Thank you, Mr. Soumitra and Dr. Brian, and I think few of them I know, Mr. Ron and Paul, I know them. So anyway, thank you. It's a excellent community. And my World Talent Economic Forum, I have a small communities from grassroots level, and definitely I get a lot of support from Western world. We are developing in Bangladesh right now. So I have something I want to share, because you have a brilliant knowledge, you have a brilliant platforms, but I think that in terms of culturals and grassroots level communities, you need to add something. First thing first, as I also move around the world and I attend all of the COP and many interesting conference and projects, I find that there are something we need to add. Recently, I published a book. It's agro-entrepreneurship. I think Brian working on food securities. This is very, very helpful for Bangladesh. Secondly, you will be interested, I think we have to know that the local farmers, example, in Bangladeshi farmers, they are very innovative. And they have more than 3,500 innovation in agriculture. They are very good scientists, but unfortunately, the scientific communities or the corporations or the government, they never recognize the Bangladeshi farmers' innovations. So you will find the 3,500 innovation in my agroeconomics book. It's published in Lambert. This is one thing. Second things, I want to appreciate all of you, especially Mr. Soumitra. He want to organize his workshops. Definitely, I work in Dhaka University and Daffodil International University as a professor. So I want to welcome you all in Dhaka University and Daffodil University. I discuss with my authorities because of some political issues. Maybe we have to wait another few months. But I want to invite you all. But most important factor is that what I see in this COP, I'm sorry, maybe there are different perceptions, but I'm just sharing my perceptions. And the climate initiative and everything, you can go to all of the emerging economy. And if you go to grassroots level people, if you say there is an impact, do you know that there is an impact for climate change? I think almost 99% people will say to you, what is climate change? I do not know. In grassroots level. So that is the reality. I can bring thousands of people and they can say, I do not know nothing. That is the reality. So how we can solve it? We have to engage with these communities. At the end of the day, all of the big countries, I'm sorry to say, all of the big bank, financial institution, World Bank and this and that, these communities and this bank, the financial institution, the innovations never help these grassroots level communities. So if you really want to help this grassroots level community, you have to engage with your innovation with this grassroots level community. Secondly, there is another problem with these politicians. All of the politicians are corrupted, especially in emerging economy. So if you work with them, I don't know what is the intention to solve the problem. Let's say in Bangladesh, when I do research, I find from climate fund, Bangladesh get fund to pot the bank. And all of the politicians actually hacked the money. So grassroots level never engage with this finance. So So how do you solve these things? So I actually do not want to go for complain and do all of the things. So I engage with the grassroots level community, and I find that the microfinance, it also has huge interest. Poorer become more poor with this microfinance, but this Islamic finance in Muslim community, it will be very powerful to solve this problem. This is number one. And number two, that climate finance, what always we trust the politician and give this money to the politician, like the politicians and everything, and they hack the money. Better if we engage with like global north and global south with proper financial channel and engage with this grassroots community, that is one and only solutions we have. You know, the Silk Road was the one of the beautiful things in Asia Pacific. I think Mr. Brian in Asia Pacific, and he know the Silk Road beauties. And China also go for Silk Road through 2.0. But with this North American, I know all of you are brilliant mind, all of you have beautiful hearts, all of you are trying to help the global communities. I saw a lot of beautiful things in global North. On the other hand, and you have a lot of tech companies. In global south, we have a lot of people. We are the future. 56% to 60% young population is here. So if we work together like Silk Road 3.0 and we deploy your innovations, we welcome the grassroots level innovations and engage with this climate finance and Islamic finance in a proper way, that is the beauty to solve the problem. Otherwise, we will organize it, all of the big universities, all of the top conference, all of the things, it will not work. But I'm happy to say with my concept, many financial institutions, many innovative solution providers, universities, grassroots level communities, I'm developing like a community in Bangladesh right now, and they become very positive and they are helping me a lot. So I want to welcome you all in my grassroots level initiative. And Brian has brilliant presentations and Shumitra has all of the interesting things. So this way, you really can involve with these things. Otherwise, the government model, large corporation model, I don't know. I never seen last 15 years it work. I never seen. But I want to say 90% grassroots level communities are good.
Yeah, I would say
they have beautiful mind. We have to work with them.
I agree.
Thank you.
Thank you.
My pleasure, Dr. Sharif. And I think you bring up an interesting point, and that is it's going to take decades for us to do the first two legs of the climate triad, and that is emissions to zero and 2,400 gigatons of carbon dioxide removal. The third approach, the climate repair approach, we've seen with the negative experiment of the IMO, a response time scale of just 6 months. And so when it comes to grassroots support, the reason I think we need to research and demonstrate a small trial and tests at this point is that the time scale, when the grassroots demands some action on the part of local and regional and state governments, they're going to be turning to climate repair approaches to try to address climate crises. And thus, the opportunity is to understand these approaches well enough at small scale so that when it becomes critical to act, that in fact this can be done. And so I would look to climate repair is one of the few approaches that will have a time scale that's relevant for political action. And that's what we hope to bring forward in a transparent and socially responsible way by starting now with small projects and public-private partnership. Thank you.
Thank you. Thank you, Brian. I will end, it's almost more than the time we allocated. I want to respond to that question, that how, it's a difficult question, that how do you get everyone involved, last 30 years or 50 years, whatever number of years you can take, we have been working on this. You can't expect that in one day the things will change. It's not. Nobody should expect that. If you expect that, then you are going to be disappointed. You have to have a longer time horizon for yourself and have a long-term plan and a strategy how to get there and be flexible towards that. My observation and my feeling at this point is that tipping point in global south has come. I'm not talking about the climate tipping point, because when people see the Dhaka and Kolkata and Mumbai are going to be underwater, and they see the climate refugees are already growing, it happened so far to the people who are invisible all the time. I mean, they are so poor, they're the marginal people. It did not affect the middle class, but it is affecting middle class now in terms of many different things: inflation, food insecurity, water crisis, floods, and climate refugees. So we are coming to this point when there isn't a demand is coming from a lot of people, not that huge in the sense that changing, toppling that government demanded, but that point has arrived that if we push it further, the tipping will be the other side. There will be further more demand. And that's the hope I have. How long that is going to take, I have no idea. But we have to give it a try. We have to continue this effort. We have no other choice.
That's a great point, Sumitra. I've had some climate scientists say that there are no tipping points, but I think you've just identified perhaps the most important tipping point, and that is the tipping point of the will of the people.
Yeah, and that's what I'm noticing, that I have been working with the flood victims since when I was 12 years old. That is the time I started working with the flood victim. It is very different when it happens, affected the people. People who are affected, the feelings and desperation is very different than the people who are not. And when this is going to affect the people, you know that happen, things are changing.
Thank you.
Not too far.
I just want to make one more point that nobody's mentioned. Especially with the U.S. political situation, if they become a petrostate, what country is really doing the most on climate change in the entire planet? And that's China. Their solar power is doubling. Solar electric generation's doubling every 3 years. So next year it'll pass nuclear, the total solar electrical output, and then it'll pass wind in a few years. And then within the next 8 to 10 years, it'll increase an order of magnitude over today. So it will pass all other sources of electrical generation. Also, their EV technology is probably better than Tesla's, and they can build cars. They're building massive new plants to supply the world with cars. Of course, there's 100% tariff in the US and Canada. There's not in a lot of European countries. In Baku, where I was, many of the cars on the streets are the BYD 15,000 US car for things like, Uber, or like dial up on your phone a car is instantly there. It's cheap to get around anywhere on the city. Also, China's battery storage is making huge leaps and bounds connected with the cars, but also large scale batteries. So for these ideas, we need to overcome. I mean, naturally, we try to set up partnerships with people who speak English, our language, right? But we need to find connections and people in China, because that's the source of huge funding to do these things. They can be done off the coast of China, for example, kelp beds. And I'm sure there'll be very little opposition. If you convince people within the government this is what to do, it'll be done. Funding will appear the next day and it'll be done, right? That's the way their system works. So nobody's mentioned it here. I think it's a very high probability of making progress in any of these techniques through people in China.
Yeah, I think it's a great opportunity to reach out globally. And you're right. I think the solar is now reached a point where the International Energy Agency has confirmed that solar PV is the cheapest electricity in history. And as a result, we're leaning in heavily to marine solar as an approach for raising and lowering our platforms, for enabling sea spray to be regenerated and to do it cost effectively. And so we're looking forward to doing more with that. And
I just before I forget, sorry. The last point is that people say, well, China builds a new coal plant every week or two. China's emissions, about half of analysts who look at China, they think emissions in China will be peaking by 2025, which would be about 4 or 5 years ahead of their plan. And yeah, so that's an aspect that China is the renewable industry is accelerating so quickly. It's basically going to be unstoppable around the planet because it's cheaper than the alternatives. It's cheaper than so. It's important for Western countries to realize this and to get cooperation with China to build their electric cars. Like if BYD built car plants, went to the car manufacturers in the US and Canada who are very protective of their car industry and said, look, you guys won't exist in a few years. Why don't you join with us, build some plants, we'll share in the profits, we'll show you how to do it. We can revolutionize electric cars in your countries and so on. I mean, I can see that sort of thing happening, but what I see happening in the geopolitical front is China's starting to be painted again as the enemy, as a competitor, right? If you look at the foreign affairs people, they're all talking that way. Canada just announced a new Arctic policy. I was at an Arctic Net conference all last week, and Friday before the conference, Canada announced instead of calling the Arctic the Canadian Arctic, they call it the North American Arctic. And the Canadian politicians were talking about incursions of Russian ships and Chinese ships through the Northwest Passage because of all the lack of sea ice, etc. And you can actually see, a lot of foreign affairs people that you'll talk to, they'll say, well, what about the autocratic nature of China? What about the human rights? What about, they want to go after Taiwan in 2027. They're building up. That would be a total mistake, I think, if China was ever to do that. I don't expect that would happen because they don't need to. I mean, they've got such a big country geographically, population-wise. They don't need to sell stuff to anybody else if they don't want to, and they can have thriving industry, and it can all become based on renewables. So I really think that you need to kind of look at all those factors. And China would provide enormous funding for this sort of marine cloud brightening. Probably the best to do it off China, though, right?
Yeah,
They want to do it off the U.S. to start off, right? The U.S. would then say they're doing a secret weapon off the coast of California or something, or or they're already doing stuff with their drones over New Jersey. I mean, there's so much paranoia in America.
I will, almost time is over. Thank you, Paul. I'm completely, with you in the sense that we should reach out to anyone, not painting anything, anyone that no enemy or competitor. Climate is everyone's problem. It is China's problem, US's problem, India's problem. It's a global problem. So if we work together as the whole country, the whole world, I do not like this conflict that is going on today. Nobody likes it, I would bet. Normal people like us probably would not like it. But as a group, if we work together, that would be the best thing. Ron, you are the last one in this. Please.
Ron's muted.
Yeah, I got it. I appreciate what Paul just saying. I also want to say that India is making massive changes and developing solar in a similar manner. And as far as the electric vehicle is concerned, a group that I'm working with has built a prototype, started in China, was derailed by COVID, and is now building a 100% solar powered transportation system in Gujarat in India. So if any of you are interested in that, I've left a couple of URLs in the chat for you to check out.
Please
Thank you.
So thank you, everyone. Really wonderful presentation. I like the interaction. That is the best part when I see everybody's talking. Love that part. This is the best part. Just wanted to let you know we have another presentation on Friday that is on stratospheric aerosol injection by Douglas McDonald from Cornell University. And that is going to be at 10 a.m. Eastern time. Unfortunately, that is bad time for the Australians. But, I'm just... but sorry about that.
Dimitri, you said Douglas MacDonald. I think you meant Douglas McMartin.
Right, Douglas McMartin. You're absolutely right. Douglas McMartin from Cornell. Right. So we'll see you that time.
Wonderful.
Thank you.
Thank you very much. Very good. Thank you, Brian.
Thanks, Brian.
Thank you, Paul, for joining.
Thanks. See you next time.
See you.
Thank you.